Let's talk about reduction. The section Aggregating Operations describes the following pipeline of operations, which calculates the average age of all male members in the collection roster. So here the roster is a collection. We get an object stream, which is the members in the roster. Then we apply a filter. The filter takes a predicate, which filters out only the male members. Then we pass it to map to int. Map the object stream into an IntStream. The map function is person get age. So we get a person and we translate it to the age. So we get from object to int. With that stream of int, we calculate the average. Average is a terminal operation which terminates the stream, and we get a double optional. In order to get the final value, we call the get as double to get the final value from the double optional. And if there is a value, we get it. If there is no value, we get an exception. The JDK contains many terminal operations, such as average, sum, minimum, max, count, which is a mathematical concept. We already know what they are. For example, if you get the average, we know it's the average of all the integer add up, then divided by the by the count. The count, as we know, is how many elements in the stream, and smallest one and the largest one. And those are mathematical concepts. However, what we need to mention is stream. Okay, let's first check. This is for IntStream. If we check the stream API, there are IntStream, LongStream, DoubleStream. We totally have 3 types of primitive streams besides the object stream, which is stream. The stream have a store object of type T. IntStream store primitive int. LongStream store primitive long, and double store primitive double. Those 3 have the sum, count, average, and minimum, maximum count. So those 3 have parallel methods, but with a little bit different. First, let's check the IntStream. Let's go through the classic examples in the library. In order to get a sum, we first get an object stream, then we filter it, then we convert the object stream to IntStream with a converting function. Finally, we get the sum. This is what the example tells us. And let's check out the operations. We have count. Okay. Count returns the count of elements in the stream. It returns a long. Instead of int, it returns a long. The count returns a long. And it's equivalent to translate your element to a number, and you do the sum. And there is the average. Average, you calculate the optional double. Note that it's optional double instead of optional int. The reason is your stream store int, but the count could be a very large number. That's why we use long instead of int. Here, the average, even though your member is int, the average could be double. That's why we use the optional double. If we check the optional double, there is a container object which may or may not contain a double value. If a value is present, we'll return 2. Get as double, we'll return the value. In order to avoid the null pointer exception, we can optionally give a default value or else. So in case your stream is empty, we want to return you a default value. That's how we do that. We call that or else, give it a default value. There's a if present. If your stream returns a value, if the optional double have a value, you can consume it. You can pass in a double consumer to consume it. If your stream is empty, then you do nothing. So you will not see null pointer exception. You will not see any. It's null pointer exception if value is present and the consumer is null. Okay. If your consumer can consume, you will not see null pointer exception. That's the design of the optional double. We have C, the average, we see count, we see max. Okay, max return you an optional int because it's trying to find the largest integer in your stream and return your optional int. Like optional double, it has the same interfaces, is present. You can will return 2. And get as int will return value. You can supply a default value, give a int, and you can have a if present, give a int consumer to optionally consume the element if there is any, otherwise do nothing. The only difference is this is optional int instead of optional double. And here we have minimum, again return optional int. We have some return an integer. Those are the details we need to remember when we go into the OCP JP. This is int, this is int, this is int, this is count return long, and average return optional double. We need to mention the summary statistics. Summary statistics is needed because those aggregate operations are terminal operation. That means they consume the stream, and your stream end up here. Once you calculate the average, you can no longer calculate the count because the stream already consumed. Sometimes the stream is just one time, like you have a say you have a you have a stock market stream. It's changing all the time. You cannot run it the second time, expect to get the same stream. So in that case, you need to count all those things at the same time. That's why we need the summary statistics. You apply the summary statistics function on the IntStream, and it return a int summary statistics. Inside this method, you can get count. Okay, return long, get average, get a max, get a minimum, get sum. You can get all those things from a single stream with just one core. This is usage of the summary statistics. It will return a summary statistics, int summary statistics. We already go through the IntStream interface. We can check the LongStream and DoubleStream It's just very similar. It's go in parallel. So even the example is the same. We get the widgets, we count the sum, and if we going down here, we see the um, average. Okay, we see the average is return optional double. It's instead of optional long, it's return optional double because the average could be fractional, exactly like before. We have the count return long as before, and we have max return optional long, different than before. Last time we return optional int. Here we return optional long, and the optional long is the same as before. It's you can supply a default value. You can send in a long consumer to consume the result if there's anything. Otherwise, do nothing. And if we go back, we can find the minimum return optional long is the same. Some return a long, and we also have a convenient method called summaryStatistics, which get all of the above in just one core. We call summaryStatistics on a LongStream, and it return a long summaryStatistics, which can get you the count, max, min, sum, all those things in one core. And if we check the DoubleStream, we see that again. Okay, even the same example, and we have the count. Okay, count return your long, and we have the average return your optional double as before, and we have the minimum return your optional double. It's not optional int, not optional long, it's optional double because your double stream store double. And again, we see the same thing. We can supply a default value as double, and we can find the if we can consume it by sending a double consumer. If it's present, we consume, otherwise do nothing. And if we go check the sum, again, it return double. Instead of int, instead of long, it return double. Finally, we have the convenient method which apply to the double stream summaryStatistics, which return the double summaryStatistics. We can get all of the above in one core. We get the average, get the long, get count, max, minimum, sum. Okay, just mention this. It's parallel, but with a little bit difference between those three primitive stream types. The object stream, okay, which stores an element of type T, only have a minimum, maximum. It don't have the summary. It don't have the average. It don't have the summaryStatistics. Because if you want, it have count. Okay, you can count how many elements. This is common. It even return the same type long. And if we go down, we find it can map to long. Okay, map to int, map to long, map to double. So if you want to count the average, you want to count the sum, you can map to DoubleStream, map to IntStream, map to LongStream. Then you calculate those average and sum. But Stream didn't provide those methods because it doesn't make sense. You want to sum up a few students. What do you want to sum? You want to sum some number, right? Or you want to sum their age. You want to sum their weight. You have to first convert them to some meaningful stream before you apply sum and average. And However, you can calculate the maximum and the minimum by supply a comparator. A comparator told you how to compare two objects. The comparator is like Java 7 before. You apply a function when it's below 0, when it equals 0, when it's above 0. And by supply a comparator, you can compare two objects and find out which one is the larger one, which one is the smaller one. And it returns the optional with type T. Like the counterpart of primitive stream, optional also allow you to check if the value is present and get it. It allows you to supply a default value with type T. And it allows you to consume it with consumer with type T. Okay, just like the primitive stream's counterpart. We get an optional from max and a minimum. We don't have the summaryStatistics. We don't have sum. We don't have average. If you want to do that, you first map them to different streams. Okay, that's the library walkthrough. Let's go back to the tutorial. Many reduction operations perform a specific task, such as finding the average of values or grouping elements into categories. However, the JDK provides you with the general purpose reduction operations, reduce and correct, which is this section describes in detail. So this section is about reduction operations. It is called reduction operations because we have many elements in the stream, and we reduce them to just one number or one object. No matter that object is a list, is a set, or a map, just one object or one number. We reduce many to one. That's why it's called reduction operations. And generally, the science of reduction is like this. There's two types of reduction. We can reduce or we can collect. When we reduce, this is equivalent of sum. When we reduce, we first have an initial value. Then we need to tell the machine when it do the internal iterate how they accumulate a new member to the existing partial results. We already have the first two elements added, and we get a partial results. The third one is coming. How we treat it? The way is we add the third element to the partial results. Then we get the next partial results, and we repeat this again and again. Finally, we have all the elements added up together. So this reduce gives the initial value, how we accumulate the new member to the existing partial results during the internal iteration. That's a reduce. And we need to remember reduce method create a new value, a new partial result during each step of the internal iteration. This may not be very efficient when we trying to reduce the stream into an object, an expensive object like a list or a set or a map. If we create a partial result, each time we will create a lot of temporary needs to temporary hash map during the process. That's waste a lot. May slow down your performance. So in that case, we use a collect method. A collect method and trying to modify or mutate an existing container. You create an initial, you supply an initial container. Then when a new member should be accumulated, you should have a strategy to accumulate. Finally, if you have a parallel stream, you get many intermediate results. How you combine them? That's accumulator. It's just trying to modify an existing container during your accumulate. In the reduce, you generate an intermediate value. Each time you accumulate a new element, that's a subtle difference between reduce and collect. The science of reduction is not a very hard because that's our everyday experience. You want to sum up some value, you just add them one by one. If you want to put a list of value into a bucket, you can just put them to the same bucket. One element, one item at a time. So that's a reduce and collect. Science is not hard, but the challenge of this chapter is there is a lot of library classes which encapsulate many reduce and collect algorithms. We need to familiar with them and we need to recite them and use them during the test. So we need to walk through the library like library examples, like library document a lot. And today we just walk through those average, sum, minimum, count, and summary statistics for object stream, IntStream, LongStream, and DoubleStream. In the next section, we will, of course, we will talk more about the science of the aggregation, and we will visit more characters which encapsulate the collecting algorithms. So let's take our time and be patient.